This video is about radical operations. It is by Jaden Murray, Abiru Kolipara, and Grant Bowser. Simplifying radicals and basic operations. A perfect square is the result of squaring a whole number. An example of this is 4, as that is 2 squared. Prime factorization is the process in simplifying a radical, in which the radical is divided until it is a group of prime numbers.
The example on the left is a radical. N, which represents the index, is the exponent in front of the square root. X, which represents the radicand, is inside the square root. Solving a rational exponent means that the denominator is where n is, and the exponent that is raised from x, the radicand, is the numerator.
For the equation on the right, it's an example of simplification. We'll give you some time to solve it here. Pause the video if necessary. So, to solve this, first we need to use prime factorization on the 24. You should get 2 for the outside and 6 on the inside.
Explain why.
You get this because you get a pair of 2's when you use prime factorization, and when you get a pair in prime factorization, you move it to the outside of the root. To move the a to the outside and get a squared, what you need to do is multiply the index by it as many times as necessary until there is one or no examples of the variable remaining on the inside of the root. For this example, it was 2. There were 2 pairs of the index in the exponent. For B and C, they work on a similar principle where you multiply the exponent by the number of times, or by the index, until there is one or no examples of the variable remaining. So for B and C, that would result in b squared c to the 4th power. So the answer to this equation is 2a squared b squared c to the 4th power, the square root of 6bc.
There are 3 steps to multiplying radicals. First, you multiply the coefficients, then multiply the radicals, and then simplify the radical. The example below is 3 square root of 2 times 5 square root of 3. So you multiply the 3 times the 5 to get 15, and the 2 times the 3 to get the square root of 6. That's your answer.
Dividing radicals. To find a radical that must be divided, the radicals in the denominator should not be simplified, and to actually do it, you can only divide in some areas, and you can't have a radical in the denominator. The example below is the example. Please take some time to solve it. To solve this equation, first you see that there is a radical in the denominator. This means that you can actually do this. First, you simplify using prime factorization, and you get 20 over the square root of 6 over 2 the square root of 3, which equal, and then you can either multiply by the conjugate, in this case would be or you could simplify in this case, and you would get 10 or square root 2 over 1. The conjugate is when you multiply both the bottom and the top by the opposite.
Adding or subtracting radicals. First, you make sure that all the radicals are simplified before you start. For adding, you add the like radicals and then add the coefficients. On the left is an adding example, and on the right is a subtracting example.
For subtracting, you do the same thing.
In the adding example, there's an imaginary 1 in front of the first square root of 5. You add the 1 plus the 2 plus the 3 to get 6, and keep all of the like radicands to get 6 square root of 5.
For subtracting, first you see that there aren't any like radicals. So you use prime factorization until you get 2 like radicals. And so after using prime factorization, you get 3x square root of 5x minus 2x square root of 5x. Now because they have like radicals, you can subtract. In which case you would do 3x minus 2x, which is x, and you keep the like radicals. So the answer is x square root of 5x.